Let's continue the concept of order and linearity of a differential equation. Still on the chapter on introduction of differential equations. We've learned that the order is equal to the highest order of derivatives for each equation. And the linearity follows a certain concept of the linearity of ordinary differential equations. So let's start with the order here. We have 4 different equations, and let's find out the specific orders first and the idea on whether they are linear or not. Unlike the previous video where we were able to examine forms like this, okay, this is the first order derivative of y with respect to x. So this is also the second order derivative of y with respect to x. We have here the forms. This could be written as the first order of y, okay, y prime, okay, we know that one. And this is your second order, we have y double prime. So that's what we can see here, except for the third form, the third equation. So let's talk about that. Looking into this, we can see this expression here as our second order derivative of y. Of course, we have here the first order derivative of y and just the constant of y itself. All of this follows the idea of differential equation. So the order of the first equation is second. Okay, so that's the second order derivative because we have y double prime here. This is also true when you go to our second differential equation. We have the second order derivative of y and the constant y here. But what does this mean if we have this expression? This 4 here is superscript 4 is not an exponent of y, because if it is, it should be written as y to the power of 4 immediately. But if you see something like this with y and you have your superscript under open parentheses, close and open and close parentheses, this is actually a order of derivative as well. And since it's 4, so the order here is 4, fourth order. Okay, that's its expression. It's not an exponent of y, which is 4, but it's an order of a differential equation for our y. Okay, now let's talk about our third expression here. So we have here this expression, we have second order, and this is actually on the first order derivative of y with respect to x. In short, this is also a second order. Okay, and going to our fourth example, we have here second order and the first order. So this is still second order derivative. Okay, so that's still the idea for our order of a differential equation. Now, let's go to the concept of linearity. Linearity of our differential equation, specifically on the linearity of ordinary differential equation, which can be represented in this manner. You have your constant, a sub n, you have x, and you have here the nth derivative of y with respect to x, and then you have here another constant, a n minus 1 for x, and you have here the nth minus 1 order derivative of y with respect to x, dot dot dot, plus here you will have a sub 1, and you will have your x, the first order derivative of y with respect to x, and you have your a sub 0, x, and your constant y be equal to a certain g of x here. If this will be followed, then we can say that our given expression or equation, differential equation, is linear in terms of ordinary differential equation. What we can see here is the idea that all of our independent variables are the same with respect, of course, our dependent variables as well. If there are other parameters that can be found there, that's just simply a parameter which you could take and a constant, and they are on decreasing order of derivatives, and each of derivatives is not raised to any other exponent. Okay, so let's have the first one here, this form for our linearity. Sorry for that. This is actually considered to be linear, because you have here the first order of, second order of y, first order of y, and y here. So you have other variables like x here and x, and this would be our g of x. There are no other variables presented there, so that's considered to be linear. This is also true for our second expression, because you have here the fourth order the second order and the first order of y, and of course you have here your t and t. Okay, so probably that would be your, if that would be the case, probably here it's your independent variable that's for your t. Okay, now for our third expression, this is where it gets complicated. Yes, we have here a second order, first order, but it's under an exponent of 2. It now violates the idea of linearity because our derivatives here are not expressed in an exponent aside from 1. So we don't have that. Or if you would like to, you can always square both sides. If you would like to remove the square sign here, you will have the square of the second order derivative of y with respect to x is equal to, so you don't have, you have no, what was one? We don't have radical expression here, but since our the order of derivatives, specifically the second order and first order, still under exponentiation here, so this still violates. This means this is not linear. It's not linear. Okay, so let's go to our fourth one here. So we have sine, trigonometric function sine theta and cosine theta, but still it doesn't violate our order of derivatives here, and it follows the concept of linearity. So this is also linear. So for these four, all of them has specific orders, but only the third one is not linear, as it doesn't follow the linearity for ordinary differential equation. So that's all for this video, and thank you very much for watching.